Hello everyone and welcome to another Math tutorial video. Now I'll be discussing Form 4 Additional Mathematics Chapter 6 Linear Law HOTS question example 4. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, let me read the question now. The following table shows the corresponding experimental values of two variables x and y that are related by the equation y equals to ab to the power of square root x, where a and b are constants. So as you can see here, this is the data of x and the second row consists of the data of y respectively. Continue to read the question. Question part A, using a scale of 2 cm to 0.5 unit on the square root x axis and 2 cm to 0.1 unit on the log 10 y axis, plot the graph of log 10 y against square root x. Hence, draw the line of best fit. Continue to read the question part B. From your graph, find the value of a and of b and the value of y when x equals to 1.44. So this is the overall question. So I hope that you will attempt this question in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solutions. So without further delay, let us start to solve the question. Let us begin our discussion for the question part A. Okay. So for the question part A, the first step, what we're going to do is, as usual, we're going to change the non-linear equation into the linear form. Okay. So in this case, the non-linear equation is y equals to ab to the power of square root x. So we're going to change this into the linear form. Okay, that will be our first step. Okay, and then once we do that, we create a table consists of square root x and then log 10 y, and once we fill all the datas into the table, then only we can proceed to the graph plotting, okay, which is the third step. Okay, so let us write down the working here. Okay, so let us write down the non-linear equation here. So given by the question, where y equals to a b to the power of square root x. Okay, so for the next step, what we're going to do is we're going to log both sides with respect to base 10. So from here, log 10 y is equals to log 10 in the bracket ab to the power of square root x. Okay, so continue to the next step. So for the left hand side, still remains the same, log 10 y. Okay, whereas for the right hand side, we can split this one single logarithm into two separate logarithms, where it will be log 10a plus with log 10 b to the power of square root x. Okay, so I hope you guys understand the working till now. So let us continue to the next step. So for the next step, what you're going to do is this square root x, we can move it to the front. So from here, log 10 y will be equals to log 10 a plus with square root x log 10 b. Okay, so we are very close to our final step. So for the final step, what you're going to do is we're going to rearrange this equation such that it fulfills the straight line equation form, which is y equals to mx plus c. Okay, so from here, log 10 y, okay, still remains the same for the left hand side. Okay, log 10 y will be equals to, so from here we're going to rearrange the equation where it will be log 10b, okay, times with square root x plus with log 10a. So from here we can denote that this log 10y representing the y-axis. So this log 10b is representing the gradient of the straight line. This square root x is representing the x-axis, and then this log 10a is representing the y-intercept. Okay, so this is our first step, guys, where we have already changed the non-linear equation to linear form. Okay, so once we already complete the step 1, now we can proceed to the step 2, where we are required to create a new table based on square root x and log 10y. Okay, so let me write down the working here. Okay, so please wait for a moment, guys, where I need to prepare a table consists of x, y, square root x and log 10y. So please wait. Okay, so let us insert the 4 variables here, where consists of x, y, square root x and log 10y. Okay, so the x variable consists of the value 2, 3, 4, 5, 6. Okay, for the value of y, 3.39, 2.92, 2.63, 2.34, okay, and then 2.12. Okay, this is the existing data, guys. So from here we are creating a new data, which is square root x and log 10y. So square root x, so when x equals to 2, so square root x will be square root of 2. Okay, just for an example, guys. So from here square root 2 will be 1.41. Okay, and then followed by square root 3, 1.73. Okay, square root 4 is 2. Okay, since we are following 2 decimal place, so let us write it as 2.00. Okay, so square root 5 will be 2.24. Okay, and then the last square root 6 will be 2.45. Okay, so continue with the log 10y. So from here log 10 3.39 will be 0.53. Okay, and then continue log 10 2.92 will be 0.47. Okay, and then log 10 2.63 will be 0.42. Okay, and then log 10 2.34 will be 0.37. Okay, and then the last log 10 2.12 will be 0.33. Okay, we have successfully created the new table based on square root x and log 10y, guys. So once we have already do this, now we can proceed to the third step, which is plotting the graph. Okay, by the way, I've already completed the graph for you, so allow me to show you the final graph. Okay, so this is the complete graph, where consists of graph of log 10y against square root x. So this log 10y is the y-axis, and this square root x representing the x-axis. As you can see here, this is how your straight line should look like, is in the negative slope. So your graph should be literally going down. Okay, so let me close this for now. Okay, and then let us continue our discussion for the question part B, where we are required to find the value of A and B. Okay, in this case we are going to begin with the question B part 1. Okay, so for the question B part 1, we are going to approach with 2 steps. So the first step, what you're going to do is we're going to find the y-intercept first, and then once we find the y-intercept, the second step we're going to proceed with finding the gradient of the graph. Okay, so let me write the step now. So from here, step 1, okay, so this is our first step. So now what you're going to do is we're going to open the graph paper, and then we're going to look what is the value of the y-intercept. Okay, let us open it, zoom in. Okay, so this is your y-intercept. Okay, so let us close this. So from here, from the graph, so we have already find out our y-intercept is equals to 0.8. Okay, so this 0.8 we find directly from the graph paper. Okay, but then there is another y-intercept value, guys, that you have already found through the equation, which is log 10a. So for the next step, what we're going to do is we're going to compare this log 10a with this y-intercept that we have obtained from the graph, and then from there we should be able to get the value of a. So from here, compare with log 10a. So from here, log 10a is equals to 0.8. So to find the a, what you do, you perform the anti-log. So from here, 10 to the power of 0.8. So you calculate this, you should be getting your value of a approximately 6.31. Okay, so this is your first solution. Okay, let me underline the solution. Okay, so once you've already find the y-intercept, let us proceed to the second step, where we are required to find the gradient of the graph. Okay, so let me write down the working. Okay, find the gradient of the graph. So from here, the formula to find the gradient of the straight line is given by m is equals to, okay, let me write down the formula here, y2 minus y1, okay, and then you divide with x2 minus x1. So this is the formula that we're going to use in order to find the gradient of the straight line. Okay, so let me underline this. So let us open the graph paper now. Okay, as you can see, I've already labeled 2 new points, okay, over here, which is the first coordinate is 1.0, 0.61, and then the second point is 3.0, 0.23. So what I do is I form a triangle between these 2 new points, and then from there I calculate the gradient of the straight line. Okay, so from here, y2 minus y1 will be 0.61. Okay, you minus with 0.23. Okay, and then you divide with x2 minus x1, which in this case is 1.0. You minus with 3.0. Okay, so you calculate that, you should be able to get the gradient of the straight line. Okay, let me close the graph paper and continue our working. So let us perform the calculation. So from here, m is equals to 0.61. Okay, and then you minus with 0.23. So sorry guys, it's a bit lagging. Okay, and then divide with 1.0. Okay, and then minus with 3.0. Okay, close bracket. So let me underline the fraction. Okay, you calculate this, you should be getting the gradient of the straight line is equals to negative 0.19. Okay, so this is your first step. I mean, the first step within the second step, guys. Okay, so this gradient be obtained directly from the graph, but then there is another gradient that you have obtained through the equation here, which is log 10b. So for the next step, what we're going to do is we're going to compare this log 10b with the gradient that you have obtained, which is negative 0.19. okay, so let us continue. So compare with log 10b. Okay, so from here log 10b is equals to negative 0.19. So to get the b, what you do, you perform the anti-log. So b will be equals to 10 to the power of negative 0.19. So from here you should get your b approximately 0.65. okay, so this is your second solution. So let me underline this. Okay, so let us proceed our discussion for the question B part 2, where they ask us to find the value of y when x is equals to 1.44. okay, so we have already come to our last part of our discussion. So part 2. So from here, when x is equals to 1.44, okay, some students, what they do is they immediately take this 1.44 and then they take the value directly from the graph. Okay, you should not be doing that, guys. Okay, you should be really careful, particularly in this type of question. So take a look at the x-axis in the graph paper. It is actually square root x, not x itself. Okay, so you should be really careful here. So when x is equals to 1.44, so from here you compare with square root x. So from here your square root x will be equals to, so you need to square root this value, guys. Okay, square root x is equals to square root 1.44. okay, you must square root this first. So from here you should get your square root x value is equals to 1.2. okay, so once you do this, then only you can use this value where square root x is equals to 1.2, and then you look at the graph paper. Okay, so let us take a look at the graph paper. Okay, so this is your value when your square root x is equals to 1.2 here. Okay, so when you pull it at the y-axis, I mean in this case is log 10 y-axis, so from here you should get your log 10 y is equals to 0.57. okay, so let us continue our discussion. So from the graph, when square root x equals to 1.2, so comma, you should be really careful, guys. It is not y, it is actually log 10y. okay, so log 10y is equals to 0.57. but then this is not the final answer. The question asks you to find the y value. So in order to find the y value, what you should do, you should perform the anti-log. Okay, so from here y will be equals to 10 to the power of 0.57. okay, so you calculate this, you should get your y approximately 3.72. so this is your final answer for the question B part 2, guys. Okay, let me underline the solution. Okay, So that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give your thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future, and not to forget to share this video. Any comments, feedbacks, please feel free to put in the comment section, guys. Thank you everyone for your support, and I'll see you in the next video.